Hi everyone. Today I'm gonna introduce about chapter 7, survey sampling and inference. Mostly I did talk about samples from chapter 1 to chapter 6. Um, so I did mention a little bit about populations in chapter 1. Today I'm gonna go deeper in it and the way to do serving sampling. Okay, so let's get into section 7.1, learning about the world through surveys. Okay, so in this section we're going to distinguish between populations, sample, parameters, and statistics. Right? And then we identify the possible sources of bias in survey. We want to identify the features of simple random samples. All right, so let's get in. Let's start with populations and parameters. Okay. So populations is a group of objects or people where we or people that we study, right? So let's say if I study about the age of married student, then populations right now is all the students at merit. If I change my study to be the age of student in math 13, right? Then I just gonna focus on all the students in math 13. Maybe in session with me, in session with some other instructor. So population now is all the math 13 student at merit. Okay. So what about parameters? Parameters is the numerical value that's characterize some aspect of the population. For example, if I talk about the average, right? The average in samples is labeled by X bar, which is sample average samples. I mean, or we call like sample mean, something like that. In here, we have for parameters, is like a population average or population mean. All right. We also learn in sample with standard deviation, right? As the S, right? It is in parameters. It's going to be population standard deviation. Right. Okay, so that is for parameters and so on, something else. all the number in population. Okay. Some more examples for population and parameters, right? So, okay, so data is gathered on the height of all NBA basketball players. The mean of the data is calculated. So, what is population in here going to be? It's all the NBA basketball player, right? So what about the parameters? It's going to be the mean height of all NBA basketball. Okay. So that you can understand the parameters for the population. Okay. So let's move. Okay, so how to measuring the populations? Census, right? Census is a survey we measure every member of population. So census is a survey that measure every member of population. And most populations are too large for a census, right? So we study population by measuring sample instead, okay? So let's we go to the next slide. We talk about sample, right? Because mostly when most population is stupid unless your study is a small population, such as just Mr2 student math 13 in math 13 class. I mean, that's one. And that's going to be a small populations. Okay. So samples is so let's talk now. Let's come to samples. So samples and statistic. So a samples is a collections of objects or peoples taken from populations. Okay. And a statistic is a numerical characteristic of samples of data, because a statistics is used to estimate the value of population characteristics, which is parameters, right? So it's sometimes called an estimator. Like you know, so that means what? So that means statistics can estimate the parameter. So let me make it bigger. Okay. So like if you want to know the mean height of NBA players, it could be almost possible, I mean impossible to know it. But you can like find a sample mean height of NBA player and then estimate the parameters, right? So another example for the sample statistics. A researcher is interested in studying the height of American women. Okay, so look, take a look as the study right now, right? Now I can know that the populations is all the American women, right? Populations American women, right? So can you have all the American women? Oh wow, that's gonna be almost impossible. But instead of doing that, Sui group takes a random samples, right? So you could take only a random sample of 1,500 American women. So now you have only a samples that have just 1,500 American women, right? 1,500 American. So, and then you're gonna find the mean height of the samples, right? So this 63.6 so inch there is just for the sample mean. It is sample mean. Okay, sample mean. The sample is the 1,500 American women. The statistic is sample mean of 63.6 inches, like I state above. So the researcher may estimate that the average American woman could be around 63.6 inches tall. You remember that I'm using the word estimate, right? So this could be around that, right? Now, let's talk about statistical inference. Statistical inference is the art of science. Of drawing conclusions about a population based on observing characteristic of sample. So let me highlight it. Statistic inference is the art and science of drawing conclusion. All right. So basically, we want to make a conclusions about the populations based on samples, right? Based on sample, and it involves uncertainty because the entire population is not being measured. Is let me use other color. an important component of statistical inference is measuring our uncertainty. So let's move to an example to understand about that. In January 2015, the PRC published a report stating that 37% of Americans believe that genetically modified food, so GMOs, was safe to eat. So what is important information in this sentence? I would say 37% of Americans believe that, right? I believe the GMOs were safe. Believe GMOs safe. So this is this a parameters with characteristics come from populations, or is this a samples statistics? I mean, a statistic which is characteristic come from sample, right? So so let's so keep in mind that mostly the research state will be the parameters, right? Because that is like a completely a research done and got out an estimate or even like a perfect parameters for the whole population's audience. So these must be a parameters proportion population proportion of all Americans. So this will based on a survey. So take a look at the second sentence there. This was based on a survey of 2002 American adults. So that means what? They did do a research with a sample with a sample size of 2002 Americans adults, right? They asked those people that, do you believe that GMOs were safe, right? So after that, they estimate the percent of the all Americans believed about GMOs was safe, right? So we're gonna identify the populations and sample. So population in here should be what? American adults or Americans. That's enough, right? And sample 2002 American adult. Right? So the parameters of interest. So because we have population is Americans, right? So what are you interested in right now in this population? We are interested in the population proportion with P. People who believe. I may have to move this a little bit to the left. who believe GMO was safe. And statistic will be some proportion, right, of people who believe in GMOs were safe. So so I would say up here is parameters. And this will be statistic. Yeah. So let's take a look at what we have in the answer key. Okay, so let's move out. Right. And I mean, clearly statistics in here um, is 37%, right? Of the people who feel that GMOs are safe. Keep in mind that percentage is the same as proportions, but just write like when I say that percentage is proportions right in percent form, right? So proportion is a decimal number, and then when you multiply 100%, it's gonna be a percentage, right? So let's so let's move to. So the next slide talk about the difference between statistic and parameters. According to the previous slide, you can understand some, but let's see. Statistics and knowables, right? Anytime we collect data, that we can find the values of statistics. That's all. Right. Parameters are typically unknown because we usually can only estimate it from statistics, right? And this estimate will involve some degree of uncertainty, right? Because we need to have like a range, like a margin errors later, so we learn that, right? So that's the difference between statistics and parameters. Okay. So let identify parameters or statistics in here. Consider these two sentences from the New York Times, which is in November 5th, 17. In election day, exit polls, 81% of those who describe themselves as conservatives say that had voted for Donald J. Trump, right? And the second question, the second sentence is, Winston Churchill painted more than 500 pictures in his lifetime. So what's the question? Is the number 80% a statistic or parameter? So let's come back to here, right? These 81% of those who describe themselves as conservative say they have voted for Donald Trump. So if that's a statistics or parameters, as you can think, this is not the whole population's you know all of all Americans. It's just an excess pose in so it's gonna be just a statistic. Okay. Okay, so is the number, find us over here, a statistic or parameters, right? So this is a parameters because it's describe the whole populations that that's the collection of all Churchill paintings, because you can see in here state that Winston Churchill painted more than 500 pictures in his lifetime. So that's what you guys is supposed to be parameters. So let's move to the notations. All right. We have learned about sample mean, which is using notation as X bar, right? You see that? This is for statistics, like I told you, right? And we did learn about sample standard deviations, which is S. We did also learn about sample variance, it's just square of the S or S square. And also the sample proportion, which is P hat, right? Okay, since today we did learn about the parameters, right? And we're gonna learn about population mean. We learn about population standard deviations, right? It's a sigma here. Usually, I mean, you sometimes see it from the previous chapters, but now it's officially you understand that. And population variance also is sigma square, right? And for the populations, it's gonna be just a P without the hat. Okay, so that's all we have for notations. Okay. Let's talk about bias. A survey method is biased if it has a tendency to produce an untrue values. Right? We have like 3 types in here you have to consider. Okay. First, measurement bias. Secondly, sampling bias. And third is use an estimator that's biased. Okay, so let's go in detail for the first type, which is measurement bias. Okay, so measurement bias is a result from asking questions that do not produce a true answer. And it occurs when, so do not produce a true answer. And it's occur when measurement tend to record value larger than larger than the true value. For examples, if I asking people, how much do you weigh? Oh, wow. If you think about asking this question with, with the people who don't like to tell you to choose, right? Is you will get not a correct information, right? So you can see that people will report likely a number less than their actually weigh. In Americans, usually it's less than, but in my home country, Vietnam, people likely to get like a higher, like a you know great greater than the actual weight, because usually in there people want to be more, heavier. So the result things in here, in this research we'll get an estimate that tend to be too small. All right. So let's see. So that is for the measurement bias, right? Some sources of measurement bias, such as like it can occur in a variety of situations, including self-reporting of personal data, right? And the use of so self-reporting, the use of confusing wordings in surveys, right? And the use of non-neutral language in the question, right? So those will make the measurement bias. So we move to the next case when we have sampling bias. So sampling bias occurs when using a sample that not representative of populations, right? So occur when using sample not representative of the population. So, for example, if I do internet polls, and most people who answer this poll tend to be those who have strong feeling about the result and are not necessarily representative of the populations. I will give you another case, such as like if you you want to do a research about the average age of student at merit, let's say that, you try to look for, not look for like a random people, you look for some some old people, or some let's say just look for some very young people and ask about their age. So that will make a bias for the sample, right? Because you actually missing some people who older, right? Who are older. Okay, so that is about sampling bias. So here's some important question to ask about sampling. What percentage of people who asked to participate actually did so? So right. And Did researcher choose people to participate in the survey, or did people themselves choose to participate? So this will make, will make sure, will tell us about if the sampling become biased, right? Okay. If a larger percentage of those choosing to participate refuse to do so, or if people themselves choose to participate, the conclusion of the surveys are separate, right? So, identifying source of possible bias. So let's say a school district is interested in finding out what percentage of voters in district will favor the passage of a school bond measure. The district sent out a survey to all school parents asking, say, do you favor the passing of school bond measure to provide additional resources to improve educational opportunities for the student? So identify any source of possible bias in this survey. So go ahead and pause my videos and think about what is the answer. So before making conclusion, you can go ahead and come back with sampling bias here, right? When it's occur using sample not representative of the populations, or you can look at measurement bias, right? When this is asking question, right? You can see the measurement bias happen when it's going to be self-reporting or confusing wording or non-neutral language. I got feeling this have a non-neutral language in the question, right? So that's could make a measurement bias. So in this case, right? So let's take a look at the answer for this example. So clearly, these have a non-neutral language in wording up the question, which do you favor the passing of a school bond measure to provide additional resource to improve educational opportunity for the student? So yeah, clearly this will be a measurement bias into the survey. Okay, so let's move to a very, common way to do the survey. We call simple random sampling. So this way, this sampling methods usually will help us to have a good representative for the sample, a good sample to representative for a population. Okay, so what we do is we draw a subject at a random, right? At a random from the population without replacement. Without replacement. And the random sample is one in which every member of population is equally likely to be chosen for the sample. So equally likely to be chosen for the sample. And a true random sample is difficult to achieve. That's clearly is difficult to achieve. A statisticians have developed methods for producing random samples that can be used to estimate characteristic populations. So let's take a look at the next slide. Okay. Oh, actually, this is the last one. Sorry. Yes. So we stop at here, and we're gonna talk more about that in the next section. Okay. See you later.